Welcome everyone to the next in our series of Designing for Flood Resilience. Today's all about bank stabilization practices for flood resilience, and brought to you by our funding from the BC Salmon Restoration Innovation Fund, and thanks to our partners, the Partners for Action and Watershed Watch Salmon Society, and for our amazing speakers for being here today. Without further ado, let's get into it. So I'm sitting here located on the unceded and ancestral lands of the Musqueam, Tsleil-Waututh, and Squamish First Nations. If you'd like, please feel free to toss in the chat the lands of the First Nations people that you may be on, and also just take a moment to reflect on the connection between how flood and salmon and other things connect to First Nations people in this Lower Mainland area where at least I work, and many of you. To note that that First Nations people who have been here for since time immemorial have been forcefully displaced in many cases to reserves that are within floodplains, and are also disproportionately impacted by the loss of salmon that we're seeing. It's estimated that more than, or around 90% of reserve lands across Canada are actually located in flood-prone areas. And as you can see from this map, this is certainly the case for the Lower Fraser watershed. So I acknowledge that as part of a shared history on this landscape that settlers have to take account for as well. So I'm doing that as a settler myself in this case. I should say before we continue that we were hoping to have Rick McCamey from Lecomal First Nation join us today, but he's unable. He's a very busy guy. For those that know Rick, he has a lot on the go, and this week is especially so. So unfortunately, he won't be joining us today, but hopefully in the future we'll be able to have him back again. A quick run through of our agenda today. We'll be doing presentations from our great panelists here and have a little bit of time for Q&A, and then we're going to shoot you into breakout groups, those of you that are brave enough to stick around and have some conversations about bank stabilization. We'd really appreciate your feedback. And this is an opportunity to say that we have Charlotte Milne here from UBC, and she's working with us to prepare a report on the findings that we have from this this workshop, as well as doing a lit review and some case studies on bank stabilization techniques. So your feedback in these breakout groups will actually get incorporated into a follow-up report. And on that note, actually, you can go to our website. We also have Maurizio, who was in this position last year, and now actually put together reports from our 2 sessions last year, and you can find on our website. And if I could get someone to toss the link to those resources into the chat, that would be great. Yeah, you can find those resources from last year in the reports. And another thing to say, we're a little bit short on group facilitators for our breakout group sessions. So if there are volunteers that are up for facilitating the small groups and keeping some notes, if you could message myself, that would be great. Yeah, we could use your help today. And feel free to rename yourself in Zoom. You can do that by hovering over your picture and in the rename button, add your organization if you are able. That would be great, just so other people know who's here. I think it's helpful for people to know who's all here. And feel free to chit chat in the chitty chat box as much as you like. Without further ado, we're going to have a little bit of a poll session to find out who's in the room and ask you a few questions about bank stabilization. So our first one is a very simple one. I'll wait for a bunch of results to roll in here. Great. Awesome. Okay, I'll share the results. There you go. You can see who's here. A smattering around, but lots of provincial and federal, local, regional government folks. Okay, next question. Sorry, this might be a little bit clunky. So the next one is, how much do you think about bank stabilization in your daily life? There's a lot of folks here, so I feel like wow, this is impressive. People are here because they're thinking about it a lot. I did not actually expect this. This is pretty cool to see. We definitely got the right people in the room here. Okay, I'll share the results so you can see. Pretty impressive how many people are thinking about bank stabilization and bank degradation. Okay, we'll do the techniques that you have used. Whoops, what have I done here? There we go. Techniques that you've used. This one has a little bit more text to read through, so I'll give you a little more time. Cool. Okay, it's pretty quite a lot of different techniques here. Okay, I'll share the poll here. There we go. As you can see, lots of lots of everything. Quite a lot of on the revegetation side of things too, so that's cool to see. Okay. Now we're going to do a quick kind of the same ones, but ones you're interested to learn more about, given that many of you are already doing a lot of these. You probably all have some helpful things to tell. Okay, cool. We got the right group here. Lots of people wanting to learn more about bioengineering and revegetation options. I'll share the results quick. There you go. So I think you're going to learn a lot from, hopefully learn a lot from our panelists today, and we'll be able to share on some of this stuff. And then last one. Here we go. On whether you've noticed any detrimental environmental or social impacts from bank stabilization efforts. Okay, so a lot of people are seeing those or aren't super sure about whether they're experiencing it. Okay, cool. Thanks everyone for playing along here. There's the results of that one. And we can carry on. Okay, that's all going to go in the report that Charlotte's putting together. Just to carry on and say a little bit about like the Resilient Waters Project and connected to the work that Lena Aziz started. And many of you have probably know Lena or have heard about this project, but Lena started that back in 2016, noticing this intersection of flood infrastructure and salmon habitat in the lower mainland. 150 structures cutting off 1,500 plus kilometers of habitat, but now it's changed. I see, Lena, you're making the face because there's an updated map with more structures, including in the Serpentine Nicomecal and not just the Fraser adjacent watersheds. So now we're up to 180 structures. Is that right, Lena? Yeah, with 1,800 plus kilometers of habitat, I think, or 1,700. Yeah, has been lost due to these flood pieces of flood infrastructure, floodgates, pump stations, and dikes. Today we're talking about banks because all those banks lead up to these flood structures, and I think there's just a value in talking about it. Oh yeah, so just quickly to say, from the work that Lena was doing, we launched the Resilient Waters project in early 2020 to identify and catalyze restoration opportunities related to these pieces of flood infrastructure. You can check out the link there on the website, resilientwaters.ca, to check those out, or get in touch with me if you have an interest in working on a flood structure that you think is barring salmon habitat. Then let's talk. A quick note on the Lower Fraser Floodplains Coalition. This is a group that me and Lena and others in the group are part of. This is a group that's been working since really since the atmospheric river in November 2021 on a more principled and collaborative approach to flood resilience for the Lower Mainland. And we're working basically to align with the BC flood strategy for regional work in the Lower Mainland now, as a kind of quick update, as things have been progressing pretty nicely. And the reason I bring it up is it connects here. I think a lot of you are connected to that work in the Lower Mainland, so we're going to be talking with you soon. The work that I do in the Resilient Waters Project is particularly oriented around this catalyzing of projects, and part of that is sharing information, sharing learnings, and building relationships. So that's a lot about what these webinars are about as well. So why bank stabilization? I think based on your interest, you know a lot better than I, but I'll just say that there's been a lot of interest expressed in this topic in the past. And especially after November 2021, there was lots of concern about how banks were being stabilized as results of those events. And to point out that often flood damage isn't just from floodwaters, but also the erosion that has been caused by floods. This is a cool graphic that Charlotte put together, so a bit of a teaser of what you'll probably see in the report. And this is the not so nice banks, and then you'll see probably a cool graphic of nicer banks with some cool techniques being used. Without further ado, I'm going to hand it over to Natashia to present, and you can just see her bio there while I pull up her presentation. So Natashia, thanks for joining us. I won't go through your whole bio here, but just to say, Natashia does amazing work as the program director of the Fraser Valley Watersheds Coalition. She's got a lot of great stuff to share today. Excited to see her presentation. I'll just pull it up right now. And then I will hand it over to, oh, here we go. Hand it over to you, Natashia.
Thanks, Dan. All right. So I work for the Fraser Valley Watersheds Coalition, and we're going to dive deep into exploration of techniques in considerations when addressing bank instability, with the mindset of benefiting watersheds, local waterways, fish, people, and wildlife. So taking that multi-value approach. Next slide. Or can I control the slides? Oh, perfect. Okay, so at the end of today's, or my brief talk with you, the 4 takeaways that I hope you come home with are that rivers are dynamic. Erosion is a natural process that can be influenced by human activity, but it's natural. And so when the coalition and partners set out to address a stability challenge, we need to really identify and understand what the issue is and develop clear objectives for what we're targeting. And we often use a variety of techniques that are applied together, and they have to be unique to the site and the objective of the stability project. And of course, the last takeaway that I hope you see today is that we add diversity targets into design and implementation. We have to think about not just the bank itself, but what's happening around at the landscape level. Next slide, please. So a bit about us. It's a snapshot. You can go to our website and you will see all about us. But essentially, we are a registered charity, and we've been in existence since 1997. and I think what we're most known for is actually doing the work. Next slide. So rivers, as I said, are dynamic. Erosion and deposition occur naturally within the rivers. Bars move, stream banks shift and change. And of course, in managed river systems, rivers and their thalwags can become more prone to erosion and risk as a result of changing the movement and the hydrology of the river. That image is taken at Stave River as the river shifted from its center onto the right bank. And of course, I just flag in making room for water, queuing which is more powerful. If we have more space, could it be less detrimental when we're managed river systems? Next slide. So key thing is we do identifying, understanding the challenge. So we really need to identify the scope. How big is this erosion occurring? What are the drivers? Is it a result of constant changing hydrology, like tides? Is it a result of floods, or is it a result of river management below dam stations? So understanding those drivers help to identify what options we have. And of course, what's being impacted by the results of erosion? Is it a culturally sensitive site? Is it salmon and salmon habitat? Are we at risk of losing trails and infrastructure and homes, or is it all of the above? Often it's multi-valued approach. Next slide, please. So briefly, we're going to talk about the 4 things that the coalition has used: changing stream bank slopes, bioengineering and replanting, revetment with large wood and stones. And again, I'm going to reiterate that almost always we're using a combination of these techniques. So we'll dig in a little bit. So let's start with changing soil slopes. So in this photo, it's a Little Chilliwack Creek. You can see the bank slope was almost near vertical with cut banks. And the challenge was that the landowner was facing erosion. There was a dominance of blackberry, and the erosion was bad for fish, obviously, and it didn't look, quote, nice. Now we were working we had to consider streams, we had to consider road right-of-ways, but our technique in this scenario done over 10 years ago was let's shift the bank back to that picture of nice angled 2-to-1 or 3-to-1 slopes. Next slide. So here it is. We used an excavator. We changed the stream bank and pulled the soil back. I won't get into the permits and all the things we had to do to be able to do that job, but essentially its strategy could be let's get that pulled back. Let's get that riparian gradient going up. Also in the photo, you can see that there's large wood on the site. The blackberry root crowns were pulled and dug out, and we've got burlap to help address erosion and stabilize and suppress reed canary grass, which is an invasive grass at the bottom of the next slide. This is what it looks like as of a couple days ago. Thank you to my colleague for driving up to take the most up-to-date shot. So here on top of changing the slope, we obviously replanted, and here it is over 10 years growing. The blackberry has been really reduced, and you can see even at the top of the bank, which was replanted as well, it is now growing trees. Next slide. Again, that's the top of bank just to demonstrate you can have healthy riparian areas, address bank instability, change the gradient of the slopes, and have active different uses, in this case, agriculture, up on that bank as well. So we'll go to the next slide. One of the other techniques we use is bioengineering. So I just want to say what it isn't. So it's not considered bioengineering if you're not using natural living materials to stabilize the site. And bioengineering has its place, but so does more engineered structural plans. So you really need to understand the application and use and the risk of not going harder with those more traditional materials. So things like the lock block, the gabions, geotech fabric, silt fences, they're not themselves going to grow, but they could be playing a supportive role if we wanted to go and shift into bioengineering techniques. Next slide, please. So what is bioengineering? It's the use of indigenous living plant materials to perform an engineering function, help it grow. This can include using rock, soils, plants, and wood to help stabilize steep, unstable slopes. The two that we're going to look at a little bit are wattle fence and live staking. So again, the idea with bioengineering is that we're helping it grow and we're jump-starting natural successional processes. The structure of moving up the floodplain and into the forest and riparian ecology. Next slide. So this is a picture of a more recent site we worked on. This landowner was facing a loss of land that was directly related to water and the movement of control waters as they changed out of a fish structure. So bad for farmer because they're losing their land. I'd be very concerned if that was my barn too. And of course, when you mix silt and soil in the water, it's not good for fish. So let's go to the next slide. Often in bioengineering, we need to introduce soil. Soil has been lost. It's been flushed away in the water course. We're sitting at the bottom of the creek, so we need to rebuild our organic growing medium. Next slide. So that same site this is what it looks like today. So we're essentially weaving growing materials to help it grow. You'll also notice wire cages because we have to think through not only helping the site grow, but what might it be at risk from as it's developing. In this case, we're trying to prevent impact from herbivory damage. Next slide. And again, this is what it looks like in the spring of last year. And next slide. And now we're seeing a year's worth of growth of that site, and the farmer's much more happy because they're seeing this reestablishment of their stream bank. So we'll just go to the next slide. We've got, oh yeah, so here you can see the applications you can use across a variety of different sites and systems. So whether it's helping stabilize different farm sites up the watershed, down in the watershed, vertical banks, even submersed in water, there you can use this bioengineering technique where you're weaving these live stakes and materials and growing your bank stability. Next slide, please. So when we think about the techniques, what we want you to think about what's usually used. So those pioneering species, willow, dogwood, cottonwood here in the Fraser Valley in BC. But you could use other things like a hardhack and mirror, other species that will grow. You want to collect in the dormant season. You want to make sure that you're cutting the right size for your application. Sometimes the bigger stock we'd use for the posts might not be suitable for another application. And typical things to consider is where are you harvesting? Making sure that there's no conflicts in the place that you are doing your bioengineering. So allelopathic properties, there's chemicals that can be released as a competitive edge, and you need to address that first, or your bioengineering may not function the way you want. Again, I talked about herbivory impacts. Next slide.
5-minute warning.
Thank you. Know about your acts and regulations. I just want to flag out that when you're collecting and using bioengineering techniques, you want to look out for pests and diseases as well. As practitioners, it's really important that we do not spread things that can actually cause detrimental harm across landscapes. And I'm going to get you to go to slide 25 if you can. So one of the things that we do often is put all the pieces together. So I talked briefly about bioengineering and changing the banks. We also do other large wood reef work where we're putting typical, more hard rocks and stones, riprap into the stream, but we're designing it in a way that it's going to benefit the bank stability, but also increase fish habitat. So in this case, you can see that there's a big stream bank that was eroded. That was a result of 2021 flooding. The trail was at the top of the bank. You could see the the photo there where they're flagging off was washed away and it was prone to more erosion. And so we wanted to apply all the techniques. So if you go to the next slide, we did use stones, but you can see we've driven in root wads and anchored them into the bank so that we're creating that complexity that will also shift the thalweg along the creek so it's not chewing on that bank there. And then we're stepping it up. Next slide, please. Now these are called soil wraps. So we're trying to engineer a growing medium that's also been driven in and stabilized as we walk our way up the hill slopes. So this is an example, again, the flow, and we're moving our way up. Notice we're also, again, changing the slope of the bank. Key thing here is we had to go through all of the processes, including archaeological assessments, to ensure that when we do this work, we're not causing harm to other landscape values. We'll leave that aside for another day. Next slide, please. Here it is. It's labor intensive. We've got our partners from DFO, cultural monitor on site, and contractors. This is handwork, machine work. We've got soil medium in there. It's seeded so that it grows on top of that riprap and on top of those stones and the wood. Next slide. And again, here it is at a different angle. So you can see how high up it is. Next slide. A different angle again. This is right after it was completed. Next slide again. Here it is a few months later. You can see we're planting the top of the bank. We've seeded the angular. We've got the stones at the bottom, the large wood, and we are starting the fencing of this project site. So if we flip to slide 33. So I didn't get to all of the techniques, but what I would like to say is that you want to use the combination of tools. You want to really think through the things you choose to use as specific to your site. And I just want to acknowledge all of these people and groups that have been a part of one or more of the bank stabilization bioengineering projects that we've done across the valley over the last 10 years. Next slide, please. And again, this is the 4 takeaways I hope you briefly got through my presentation. If you want the full presentation, please contact me. Thank you, Dan.
Awesome. Thanks so much, Natasha. Great stuff there, and very impressed with how much you got through that short time. Yeah, feel free to toss in things that you liked about Natasha's presentation, questions that you have. We won't get to them right this moment, but we will go to our next presenter here, which will be Steve Clegg from Say Lands. Hey, Steve. Thanks for being here today. I'll let you take over my screen here and get your presentation on up.
Good, thank you, Dan. Can you see my presentation up there?
Yep, it's showing up clear.
Wonderful. Ace Whale, Steve Telsquee, Talit Sequoia Say Lands. Good day, everyone. My name is Steve. I'm joining you today from Skokale, Atchlitz, and Yakaquius First Nations as their manager of land stewardship. Today, I've got a few topics that I wanted to cover. None of it is groundbreaking. You've probably seen it before, but just wanted to roll through a few alternatives to some of the conventional products that I see used a lot in situations where we could be using more natural alternatives, and kind of wanted to start throwing some social license out there that it is being done and it is successful. So with that context, jump in. Again, nothing groundbreaking, but we'll cover some topics here. So first up, we're going to talk about some of those conventional products that I mentioned. I've got some thoughts on those. We'll talk about some of our priorities that drive our decisions here. and then cover 2 alternative methods to some of those conventional products. First being seed and hand spread straw. The second being wood mulch berms that we've been using more and more in our restoration projects. After that, I'll throw up some topics for discussion. We won't get to them during this immediate session, but we may find ourselves talking about some of these things in the discussion groups or after. So some food for thought at the end. So let's dive right into it. Conventional products. You all know these erosion control mats. They've got a place, but from my perspective, I find them expensive. And I find that they are full of plastic. And I don't like introducing plastic to our ecosystems, especially when we're trying to restore them and make them natural again. You can get compostable ones, but again, see point number 1, that just makes them significantly more expensive. One of the big challenges, the functional challenges that I have with the erosion control mat is they don't lie flat to your surface if your surface is undulating. If you've got a civil project and you have put it in with a dozer with GPS and it graded it perfectly smooth and it's track packed in and it's all level, great. Yeah, that'll stay there if it's not windy and you've stapled it down to the ground. But if you're in a restoration site where you're aiming for rough and loose, you've got big gaps and little valleys in your soil, and your blanket is going to roll over the top of those, leaving an airspace underneath. Water is going to get there. It's going to pick up speed. It's going to create little rivulets. It's going to run right underneath your product. And you're not going to have the benefit that you thought you were for that product, and you're going to end up with sediment down towards your stream anyway. So not a huge fan of that, recognizing that it does have applications, but there are alternatives. Silt fencing as well. Do I use it? Yes, I've got some up right now. It has applications, but I try to steer away from it wherever I can. For similar reasons, it's expensive. You have to go out and purchase it. At the end, you have to dispose of it often, which also costs money. It is another plastic product. I don't like putting that out into the ecosystem. And I'm finding that it is a big migratory barrier. I've spent a lot of time watching permitted projects say they're going to use this stuff and say that they're going to take it out. And often, very often, it doesn't come back out. And it provides a barrier to migratory passage for amphibians, small mammals, all kinds of things. So much so that some QEPs are using sediment fencing as migratory barriers or exclusion fencing. It is very effective when it is installed correctly, which brings up another point. Often, I've seen many projects, including some very recently, where this isn't installed correctly and it doesn't serve its function as materials scoot right underneath if it's not keyed into the ground. And it is passive. It doesn't prevent erosion. It just collects the product of erosion before it reaches a sensitive site. And you end up with a big wad of unconsolidated sediment right up against your fence, right against your sensitive area. And because you have to, or you're supposed to, remove this fencing when your project is done, you end up with a big pile of unconsolidated fines right adjacent to your sensitive site. And when you pull that fencing, the next big rain is now going to take that huge slug of material that's piled up against that fence, and it's going to throw it into your sensitive site, whether that be further riparian, wetland, or stream environments. You haven't actually dealt with the problem; you've just delayed it in many cases. It has alternatives, and we'll jump into those here soon. But first, I want to cover some of the priorities that drive our work. One, I want things to be low tech. I've got a lot of volunteers out assisting with our projects. I've got summer students. We've got new staff. We've got neighbors joining in for the work because they want to be involved. I want things that are low tech and people can be involved in right away. I want them to be cheap. Right now our budget is healthy, but I have a habit of stretching things as far as possible because I like to get as much work done as humanly possible on the ground rather than spending it on products that we don't necessarily need and have alternatives for. Again, I mentioned earlier, I'm not a big fan of the plastic. I'd rather avoid that if I can for multiple reasons. One of those being aesthetic. We're here to restore habitat and restore streams that have been lost, and we're trying to put them back. And while we're doing so, I want it to look good while we're doing it, and I want it to have some integrity, both ecologically, but also aesthetically. So having a big line of plastic all the way down your natural site doesn't meet that aesthetic for me. I also want full soil contact. So we talked about that a little bit with the erosion control blankets. I want my products to follow the rough and loose contours of our sites if we're using that technique. Be migratory safe. So in some of our products, our critters are actually using our products as refuge rather than as a barrier. So, amphibians that need to stay moist, they're burrowing into a mulch berm, absolutely perfect. So they're contributing. Speaking of contributions, I want our products to be pulling their own weight. I don't want them to be passive, just sitting there. I want roots to be binding to soil. I want our products to be decomposing and adding to soil nutrient and building organic matter in our gravelly river bottom soils here. I want fungal growth coming from that. I want my products that I'm using on my sites to be active, not passive. I want it to be easy to plant through. A lot of those products, like the erosion control blankets, woven either with natural fibers or with plastics, either of those, you try to plant through that, you try to throw a shovel through that stuff, it's not happening. So you've hampered your planting abilities dramatically. Live stakes, pushing through a lot of that stuff, sure, you can get it, but if you end up pushing a live stake down on one of those synthetic fibers, you're pulling in your sides of your fabric, you're losing your overlap, you're getting it susceptible to wind picking it up and moving it. It's super frustrating for me. So I want to be able to plant right through any product that we're using. And a big one for me is I want it to be walkawayable. I want to install it, I want it to be functional, and I want to leave it. I don't want to consider it again. I don't want to come back and make sure that it's it's taken out. I just want to, I've got lots of things to do and I want to be able to forget about it and know that it's functioning there and know that I can leave it there long term. So jumping into the two alternatives, again, this is not new to a lot of people, but we're just going to go through a couple applications that we've been using here at Saylands. This is seed and hand spread straw. So for the most part, I'm using fall rye. If I'm throwing this down later into the fall, closer to winter, then I'll use winter wheat. It's just a little bit more cold tolerant for germination, but primarily rely on fall rye. And hand spread is big. The application for hand spread, I can go into detail, but that it's a bit of an art. But there's other ways to do it with shredding machines and blowers and things. But I'm a big proponent of the hand spread. So here's one of our sites. We had machines in there, cleaned out about 3 feet of accumulated sediment and invasive species in that stream. You can see I've already handled the far side. The close side here, you can see 2 straw bales sitting on the bank slope. We're using straw because it doesn't contain a bunch of the weed seeds. And it's not expensive stuff. You can buy this from commercial distributors, but I also went to the farmer next door and said, hey, do you have any old straw that I can use? He said, no, nothing you'll like. It's all moldy in the barn back there. I said, perfect. I want mold. Bring it on. I want to jumpstart all these ecological processes on our site. So yes, mold is great. So I went and bought this straw from him for $2 a bale. I've got 2 bales on that site, did that whole stretch of our project site for $4, added about $2 worth of fall rye seed on there. So my erosion sediment control for this site cost me about $6 and took maybe an hour or so. So it can't beat it from a price standpoint. Even if you add labor in there, it's still wickedly competitive and it's providing good results. If we zoom in close, there you go, fall rye, it's cheap. You just hand cast it. Don't worry about those big broadcast spreaders. If you've got small sites, just toss it out by hand. Lay it on there thick. It's cheap stuff, and it's going to bind in and give you a nice tight cover and a lot of root density in there. So absolutely lay it on. Here's one of our sites that we did that application with. You can see that the application has gone right down to the water. We've got steep slopes that we've applied it on. We've got shallow slopes that we've applied it on, and it's really locking that stuff in well. So this was August of last year. And then we come back to exact same site, just coming at it from the different perspective, looking in the other direction. And you can already see that there is a green sheen coming through all of that hand spread straw. That is fall rye, and that is only 8 days later. Those shoots coming out of that are already 3 inches tall. And I had a contractor laughing at me and saying, hey, you think that's going to hold as the storm it's sunny in the picture, but a storm was coming through. And he's laughing at me thinking that this was a joke. I made him come out of his machine, walk all the way around and said, go pull one of those little shoots out. So he did. He walked all the way around, tried to grab one of those shoots, yank, 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 and ended up snapping the shoot off because the roots were so bound to the soil at that point. So that whole slope is absolutely locked in after 8 days. So that changed his mind, and we weathered that storm completely perfectly with no additional sediment into the stream. As bonus points, we had wood ducks move in. These two gave us their stamp of approval and brought 35 of their additional friends here, and we've got quite a wood duck population that hang out in this section of stream now. A couple examples of that, some before and after. You see September 13th, we've got about 3 feet of accumulated sediment and invasive species choking out this stream. We pulled that out October 20th, so not too far later. We have weathered a few precipitation events, and we've got our fall rye and hand spread straw locking in the banks on both sides. It's already rooted in place. We've got no sloughing, no sediment entering the stream. We've got clean water. It's vetted by our QEP. Province and DFO gave us a good check mark for this as well. So we've had good control and good stabilization of our slopes through that practice there. So really,
4-minute warning.
Sorry?
4-minute warning.
Okay, let's cruise a little faster. So this one is one of our project sites. You can see our side cast material. And then right here, you can see water quality differences. We've got a good clean water coming in from the top, pushing down from our project sites, meaning that our prescription worked. However, up here in the corner, you can see that we've got a tractor there representing a farm field that is dumping our sediment-laden water from the farm field into the stream, and it's actually pushing back up into our project. So this one is showing that our project provided good clean water, and downstream effects through the same precipitation event pushed sediment-laden water up into our site. So we were happy with the success of our project, especially looking in comparisons to how things are faring in other sites. This spring, that's the same site that we showed you earlier, so it's really locked in tight. We've got good growth on there, and the banks are nice and solid. Moving to topic number 2, we'll blitz through this one. This is an alternative to the erosion sediment control fencing. It is using wood mulch. I love the mulch. It comes with beneficial bacteria, fungal relationships, insects in there, and adds to soil nutrient and organic material. Here's one of our sites, and the first thing you might think of is, oh my goodness, you're putting a whole bunch of soil next to a stream. But then let's zoom in a little bit at this section. One thing you'll note is we've laid a big berm of wood mulch above top of bank. It's about 24 inches wide, 8 inches thick. It's above the level of the soil. It acts as a barrier there. And then we've added our soil, planted our trees, we've got our nice rough and loose soil there. And then we come in and spread the wood mulch over top of everything, linking the surface of the wood mulch across the entire site into our original wood mulch berm, keying it right in, and it's walk-awayable. We don't need to come back and remove that. We can plant live stakes right through it. It is completely natural in there, and we're walking away from that site. The mulch berm is still there, but we don't have to go back and maintain it or dispose of any products from that site. There's 1,000+ plants planted in there just a little while later. That mulch berm is still performing excellently. Water quality results are still showing that we've got 0 sediment running into that water course. With that, I throw up, again, not to be asked or answered now, but some discussion points for later in the day. Let's talk about insulation of mulch. For the growing, extension of growing season, root development, we've had massive positive implications for that. Moisture retention, especially during climate change and longer durations between rainfalls. Drought stress in our trees is becoming a real concern, so moisture retention is a big thing. Beneficial insects, we've watched cascades of trophic profiles moving through our sites, from fungus to bugs to spiders to birds, all the way through after adding mulch. So it's pretty impressive. And then fungal growth, as we all know, mycorrhizae relationships are a growing field and super important. So lots to discuss with this. Hopefully we can connect more in the breakout sessions and after. Thanks, folks.
Amazing, Steve. That's very cool to see. Thanks for sharing all that. Okay, on to our next presenter, who is Mike Gallant from Kerr, Leidel Consulting Engineers, a senior water resource engineer and Calgary branch manager for Kerr, Leidel there, and has been working on bank stabilization, river restoration, habitat enhancement for 20 years. Mike, I'll hand it over to you.
Thanks, Dan. Give me 1 second here to get myself sorted out. I was actually getting kind of kicked in and out of the webinar, so I might keep my my video off.
Okay.
Just in case something happens there. Okay, thank you. Yeah, so presenting today, thanks for the introduction, Dan. firstly, I guess I'm calling from Treaty 7, territory of the Blackfoot Confederacy, Tsuut'ina, Stoney Nakoda, and Métis Region 3. So southern Alberta area. What I'm presenting is based in Calgary. I live up in Red Deer currently, but in the process of moving down to Calgary. Something interesting that came up in your introduction, Dan, was that you were talking about how the concern after the 2021 atmospheric river event was kind of prompting or the genesis for this webinar looking at green techniques. So the project that I'm going to talk about here, which is a case study from Calgary, was the impetus for this project as well. Following the 2013 flood, there was quite a lot of bank hardening in southern Alberta and Calgary in particular, and Alberta Environment and the city of Calgary came together to try to pilot or to try to demonstrate some bioengineering techniques that could be used more broadly across southern Alberta through this project. So interesting that pardon me, a similar genesis to this. So anyhow, so I'm going to present on some of the innovative bank stabilization measures that we included in this project, which we call the Bow River Bioengineering Demonstration and Education Project. So as I mentioned, it was conceived in response to the 2013 flood mitigation efforts. So as a partnership between EPA and what we now call Alberta Environment Parks and Protected Areas, rather, and City of Calgary. Pardon me, the first part, the design and construction, was administered under the city under EPA's FISHES program, and then the remainder, the long-term monitoring, is administered by the City of Calgary. So the project was designed and constructed 2016 and 2019. It was completed construction. And then we started the post-construction monitoring program in 2019, and that's to be finished in 2028. So it's actually three components to this project. There's the design and construction of the bioengineering components to the program. There's the 10-year post-construction monitoring program, and then there's an education component to this too, where there was a full education program that was put together on how to disseminate and kind of reduce the barriers to using bioengineering across Calgary. So the site itself, it's 720 meters to the right bank of the Bow River in Inglewood, Calgary. There's three sites, Site 1, Site 2, and Site 4. There was originally 5 sites, and Site 3 and Site 5 were removed from the contract. Hence, we're left with Site 1, 2, and 4. And within those, they're broken into between the 4 and 5 different subsites, I should say. So there's 10 bioengineering treatment areas, and there's 14 different techniques that we've piloted in each of those different techniques. And so some of those are let's say half of them are traditional techniques that we've all heard and used, and 7 of them are newer to Calgary, possibly newer to Western Canada. So starting with Site 1, it's 370 meters long. It starts on the upstream of these 2 bridges. And one of the key features to the project was to include a wildlife corridor to improve passage and connectivity between upstream and downstream of these bridges. So we really focused on making sure that happened, and we widened the area under the bridges. And the first site on the upstream end really was a gravel pad or a riprap pad that we void filled with gravel material, and then planted rooted live cuttings, or also known as tall rooted stakes. That was really intended to improve that passage, the sight lines under the bridges. And then on the downstream side of that, we have timber crib walls with vegetated soil wraps above that, and then repairing and planting. And one of those 2 sections of that timber crib wall, we included what might be considered lunker bunkers. So we call them fish shelters in the project. So that was a local lowering of the bed below the timber crib walls and supporting those timber crib walls so that there was niches underneath it. And then on the downstream, about 80 meters or so, we have a brush mattress with a rock toe, and above that, contour fascines and brush layers. So here's some photos of the site pre-construction. So you can see that lots of debris there. We ended up pulling out about 2,000 tons of concrete and steel and all that kind of debris out of the bank. This construction here, photo of the timber crib wall. You can see the live cuttings placed in there in a brush layer fashion. And then 2023, pardon me, in 2023, we came back and did an assessment on the site as part of post-construction monitoring, and you can see what it looked like in 2023. So Site 2 is a bit more hydraulically protected from the bow. So we tried some different, more vegetative techniques. There was also an existing bank swallow colony. So for the upstream, we tried to minimize our disturbance to the bank swallows, and we just put a toe fascine or a box fascine along the toe of that bank. That toe fascine or box fascine continued to the whole site. But then downstream of that, we had 3 different treatment areas. And so the first one had brush mattress with contour fascines. Second one had hedge brush layers, which is a traditional brush layer with a container plant included. And then the third one was high density live staking, so spacing there of about 1 foot or so. So pre-construction, hardly any vegetation on the bank. And then as you see the construction here in the foreground, there's live staking in the middle of the picture here. You can see the hedge brush layer getting installed. And then 2023, the growth there at that site. So site 4, one thing to know about this site is that we were kind of draping our approaches, our project over top of existing work. So after the 2013 flood, there was in this road was actually cut in half by erosion. So it was approximately 30 to 40 meters of erosion in this area. So the bank was rebuilt, the road was rebuilt, but what was left behind was quite a bit of riprap that was showing. So in this section of the project, we were piloting some ways to retrofit existing riprap with vegetation. So the upstream section, we covered the riprap with soil and went into reverse filter, then topsoil, but 600 mils, and then planted that. And the middle section, we void filled that riprap with topsoil and then planted plugs within that matrix. And then on the downstream end, we void filled that site with pit run, so a dirty gravel 30-inch minus, and then put live staking in that matrix. So some photos here. This is what the existing conditions look like on the left. You can see that there's a riprap bench there. So during construction, we tried to void fill that riprap with planting material. In this photo, we're showing the topsoil. And then this is what the site looks like in 2023. So quite a bit more growth there than existing. So I wanted to go through quickly the post-construction monitoring, so to explain a bit of the successes of the site as we've seen it, as we've monitored it over the past 5 years. Excuse me. So the post-construction monitoring, really the objective is to show how the product has improved 4 different components: the fish habitat, wildlife habitat, riparian health, and bank structural integrity. And all of that's compared back to a conventional riprap design site. So it's a 10-year program. We're monitoring 5 out of those 10 years. And so today we'll be talking about the 2023 results. And it's monitored under the program, the City of Calgary Riparian Monitoring Program, where we've looked at almost 70 different bioengineering sites across the city from 2018 to 2022. So for the purposes of the presentation, just considering time, I'm going to skip over the fish and wildlife side of things, focus more so on the riparian health and the structural integrity. But suffice to say that the fish are using the site and the wildlife are using, we've observed them using wildlife cameras, using the wildlife passage corridor. So in terms of riparian health, we've seen the significant improvements from baseline using an approach called the riparian health inventory. So site 1, site 2, and site 4, you can see the results there. So significant increases. Overall, the BDEP site scored between 26% to 39% higher than a conventional riprap site. So we're comparing that back to a conventional riprap site. And then ultimately, we've concluded that the improvements are directly attributable to what we've done in the bank here in terms of riparian plantings and bioengineering works. So in terms of the bank structural integrity, we've identified no erosion, scour, displacement issues to date. So it was constructed in 2019. 2022 was the highest flow event. It was approximately a 5-year return period event. The survival, year 1 survival, we measured that to 80%. And in terms of woody vegetation canopy cover, it increased from 31% in 2021 to 60% in 2023. So there was a significant increase in that time span. And that was almost, a lot of that was because of the balsam poplar suckering that we observed into previously unplanted areas. And so the reason that the cover was quite a bit lower than anticipated was because of the lower density planting on the top of bank and not the bank, as you can see in the front in the picture here. So looking at some more detailed results. So these are some charts I'm going to show you just to kind of give you some more quantitative information around how this site is performing. So the first metric that we were measuring is the woody vegetation canopy cover. So I'm showing it here by subsite. So there's 10 different sites here. And those roughly correspond to, sorry, what I should mention is that I'm showing 2019, 2021, and 2023. And also a cover target from the literature of 66% canopy cover. And so what we see is that for the majority of the sites that we've been monitoring, we're meeting that canopy cover target when it comes to the live cuttings. So this is the bank component of the project. And you can see that there's a couple of sites that aren't doing as well. One of them is the upstream vegetated riprap, where the survival wasn't as good as we were anticipating. Same goes for downstream, where we were retrofitting the existing riprap, and the success there wasn't as good as we were hoping. But if you can see the, thank you. You can see in the other sites now we're seeing in terms of live staking, we're seeing incredibly high rates of canopy cover, and which we're very happy to see. So now this is the top of bank results where we're looking at container plants. So now live cuttings left, container plants right. And you can see for the most part, the container plants aren't meeting that canopy cover target. So, and that's part of the reason why, as I mentioned earlier, the overall canopy cover for the entire site is a bit lower than the target we're trying to achieve. With the exception of at site 1.3 and 1.4, where that's where the balsam poplar suckering was occurring. And you can see that because of that, the canopy cover has increased substantially between 2021 rather, 2023. So, okay, so that's really quickly over the woody canopy cover. So now looking at density. So this allows us, measuring density allows us to look more closely at techniques. So on the x-axis here, we're showing all the techniques that we've included in the project, and then measured density. So that's stems per meter. So the first chart I'm showing here is linear techniques. So things like brush layers or box fascines, etc., and the soil wraps. So and again, the target here of 5 stems per meter that came from the literature. So looking at the majority of the techniques, we're meeting those canopy cover, or sorry, the density targets, with the exception of the soil wraps and the crib wall at the upstream end. But we are still, as you saw in the previous slide, getting a really good canopy cover. So in these, just to quickly, 2021 is in blue and 2023 is in orange. So they're looking at the more aerial techniques, things like live staking, potted plants, or brush mattresses. So things that we were measuring by square meter. Again, that same target. We can see brush mattresses are performing really, really well. The density, so that stems per square meter, they're up in the range of between 20 to 30, up above 40 for another site. And then live staking at site, the downstream site at site 2, we're achieving our targets. With respect to potted plants, they're quite a bit lower than the target, and that can be again because of the low density of planting that we did up there, which was about I think it was between 1 to 2 meter spacing. So anyhow, in terms of this project, we are sharing the monitoring information that we're collecting on the City of Calgary website. So this is the link to that website. Up currently is the 2021 monitoring report and the previous monitoring report. So 2023 we're finalizing now, and so you'll see the information that I presented within that report online. And we're also sharing the final program report for the repair and monitoring program, which is the results of monitoring almost 70 different sites across the City of Calgary. Again, on the City of Calgary website at the link here. So at this point, just wanted to acknowledge the partners, so City of Calgary, Alberta Environment Protected Areas, and the consulting team and contractor who designed, built, and monitored this site. Thank you.
Very cool. Thanks, Mike. That's awesome. Oh, so here we go. That's a whirlwind of bank stabilization techniques. Lots of cool stuff to think about. We're now at the end of the presentations. I think what we can do, actually, before I even show these off, is take a few moments. If there's anybody that has any questions, you can raise your hand. We won't spend too long doing the Q&A, but yeah, Natasha.
My question's for Mike. When you were doing your void-filled plantings, did you ever have conflicts where you're planting in the interstitial space in the riprap? And then there's that from the Dike Maintenance Act and that structural stability. Did you ever have conflicts where you had to demonstrate that your plantings would not pose a risk or structural integrity or failure to regulators or to the City of Calgary? And how, if yes, you did have conflict, how did you go about resolving that?
So that is a really important question, and something that does come up. But so I guess there's two things we need to talk about. One is flood protection, and the second thing is the bank protection. So flood protection, that's where the Dike Maintenance Act and Dike gets involved. So in terms of what we were doing, for the most part, the project that I've been showing was for bank protection. So and also in Alberta. So in Alberta has a different regulatory regime when it comes to dikes than BC does. In fact, we don't have anything legislative called a dike in Alberta, so we don't run across that same issue. That said, though, in the projects that I've been working on in BC, we have been, that comes up quite a bit for flood protection projects, right? For the bank protection, it's not, you still have the discussion about whether vegetation within, let's say, riprap or vegetation on the bank alone is going to cause that, issues. It's more so on the erosion protection side of things, though, right? So in riprap, and so this is just, again, on the bank stability side of things, bank erosion side of things, planting in riprap, if you look at the growth of roots around and interstitial spaces in rock, the concern might be that you will be pulling that rock out or causing instability to the rock. And it's been shown both empirically, maybe not empirically, it's not the right word, but by excavating out, that roots will grow around and not displace the rock. So that's the first thing. So that's in terms of that conversation around bank protection. Around flood protection, it is quite a bit more challenging, that conversation, because there is the Dike Maintenance Act and maintaining vegetation off the dike. And all I can say at this point is that KWL has been involved with putting together nature-based solutions for flood infrastructure for the Inspector of Dikes, a guideline for that. So there's, and that's just kind of more as indicative of the fact that the Inspector of Dikes is getting more interested, and there's the conversation happening about how to vegetate dikes so that you're not, left with a barren flood protection structure that doesn't get all the good things about the co-benefits of including vegetation in it. So I'd say it's an emerging conversation, let's say. So I don't have an answer for you at this point. Sorry.
Thank you so much for sharing your thoughts there.
No, you bet.
Okay, I think even though I know there's probably lots of great questions out there, I think what we're going to do now is head on to some breakout groups. So if you're feeling up for it, stick around. But if you're not feeling up for it, thanks for joining us so far. And yeah, and we'll see you next time. But yeah, stick around if you want to have a good conversation with some other folks. These are the questions that we're proposing to deal with here. It's going to take me a couple of minutes here to set up the breakout groups. Hooray. Okay, I hope you guys had some good chats in there. Just back out here. Wow, look at all those wonderful faces. All excited about bank stabilization. So yeah, maybe just like a couple minutes. Just wanted to like open it up. Did anybody any big learnings or questions you're taking away, or things that are exciting you? Just leave it open for a couple seconds. You can raise your hand to say it or put it in the chat quick.
We just sorry, do you want to put it in the chat, Dan, or did you say you wanted us to?
Oh yeah, you can say it out loud too, Mike, if you want. Go for it.
I have to say, we just ended the conversation on a really interesting idea. Frank brought this up, and he said that it would be great if there was a kind of a list or a menu of techniques that the regulators would accept, because there's quite a lot of conversations with the regulators currently about what is acceptable, right? So, Frank, do you want to speak more to that? Because that was a really good suggestion.
I think you've said it already, but yeah, it's one of the things. It's one of the things that we're challenged with oftentimes. We don't always have a lot of time. So when we're coming up with a fix for a problem, and we know we need to put in applications through the regulators, through Federal Fisheries and Water Sustainability Act, we don't always know what the requirements are going to be. There isn't always a good definition of what's going to be accepted and what's not. It's kind of like, well, put in your application and we'll consider it, and we'll move forward. So if there are some processes that are acceptable or even preferred, if they're documented by the regulators, it certainly will help the local governments in moving these projects forward.
Yeah, it's a great idea. Something that we can potentially continue to work on. Natasha.
I just want to say I appreciate that, and it was something that our group briefly spoke about. And I just want to say thank you to KWL and Mike, who raised that's something they're working on to help bridge the gap between flood protection, Dike Maintenance Act, and providing more tools so that we can kind of bridge the gap and build that hybrid approach. That, at least that was what I understood. So I just want to appreciate that sentiment, and hopefully it will help local and regional governments.
Yeah, good point. Regulators out there, hope you're listening. Okay, I just popped a poll up because we're running out of time here, but I'm hoping that y'all will entertain this idea and put in a rosebud and a thorn. Rose, a good thing that you're taking away from today, something that has left a real impression. Thorn, like a challenge or a problem you're walking away with. And then like a bud, something that's leaving you thinking. So yeah, I'll leave you with that to stew on, and please do. It will be really helpful for Charlotte and the report, I think, to have this kind of reflection. So yeah, like I said, oh, am I sharing? Yes, I am. Okay. So like I said, Charlotte's going to take all this info away. We're going to take what we've heard, prepare a summary report. It's going to go along with a literature review that Charlotte's working on with some case studies. We'll share the recording. I guess presenters, are you all okay with your slides getting shared as a PDF? Just a thumbs up would do the trick. Yeah. Okay, great. And yeah, I've got about 10 answers. Please keep going. I'm just going to mention quickly again, appreciation for the partners that came together, our facilitators, both that volunteered before and during the session today to step forward. Thanks very much for that. Partners for Action, Watershed Watch, and our funders, the BC Salmon Restoration and Innovation Fund through DFO and BC government. One that should be here is also the Real Estate Foundation of BC that's supporting this work too. Yeah, I've got 14 responses. Anybody still getting your responses in? Please jam them in there quick.